Hello everybody, hope you all are doing really well. Today we'll talk about how to find the minimum and maximum element in the array. So let's look into the problem statement. So given an array of size n, we need to find the maximum and minimum element in the array. So for example, if we have this as the array, it has 8, 7, 32, 11, 10 and 4. So which is the smallest element and which is the largest element in the array? Right? Think about it. It's pretty simple, right? 4 is the smallest element and 32 is the largest element. We could find this out really quickly. But how do we implement it in a code? That is the main question. How do we derive the logic? So let's take an example to understand that. So suppose I have 4 boys. Okay, I'll name these boys as 1, 2, 3 as well as 4. Okay. Now I want you to tell me that who's the tallest boy? 2, right? And who's the shortest boy? 4. It's pretty simple because how you did that, you compared the heights, right? You compared 1 and 2, 1 and 3, 1 and 4. So let me break that down to you. The comparison, I'll break it down to you. Suppose I said that I've given you only boy number 1. Okay, I gave you only boy number 1. So I'm highlighting that boy, okay, with yellow. So you can see only boy number 1, 2, 3, 4. You cannot see that boy. Okay, only boy number 1 has entered the row. Now you know that if you're given only boy number 1, he will be the shortest and he will be the tallest, right? It's simple. Now suppose I bring boy number 2 also. Now you'll be like, okay, when I compare the height of boy 2 and boy 1, boy 2 seems to be taller. So boy 2 is the tallest so far and boy 1 is the shortest so far. Okay. Now I bring in boy 3. When I bring in boy 3, I realize that, wait, let me see if 3 is shorter than 1 and if 3 is taller than 2. 3 is not shorter than 1. 3 is not taller than 2. So the shortest so far is 1 and the tallest so far is 2. I hope you got this right. Next, now when I introduce boy number 4. Now boy number 4 also comes into the line. And now we will compare boy number 4 with the shortest boy we have seen so far. The shortest boy we have seen so far is boy number 1, right? So we see 4 is shorter than 1. Yes, 4 is shorter than 1. So definitely we can come to a conclusion that 4 is the shortest guy, right? And we know that 2 will be the tallest guy, right? That is what we did. Okay. So what did I tell when I was explaining? I said so far, right? So the same implementation we'll do in the code. Okay. So here I've implemented a C++ code. So here a pair is nothing but it's an array which has 2 elements in it. Okay. So I have to return the minimum and maximum. So the return type is pair. So I'm passing the array which is provided as well as the size of the array. Okay. I'll set the minimum and maximum as 0. That's what I try to do here, right? When I had only boy 1, I made him the minimum, I made him only the maximum, right? So that is what I'm doing. And now I'll go on to the next person, next boy in our example, here the next element. Now I'll check if this new element is lesser than the minimum element I've seen so far. If it is so, then I'll set the minimum to the current element. And if the current element is bigger than the maximum I've seen so far, then I'll set the maximum to this element. Simple, right? So here, what is, I'll take 8, 7, 32, 11, 10 and 4. Okay, I'll take a shorter example here. 3, 4 and maybe 2. Okay. So first when I set starting, I'll set this itself as the minimum and maximum. This is what this line is doing, correct? And let me keep this as 5. Okay. So this will be the minimum and maximum in the beginning. Next I move to 1. 1 means this element, correct? So now I'll check, is this element smaller than 3? It's not, right? So minimum will be 3 itself. But is 4 greater than 3 here? That is what we're checking. Yes. So I will just keep two variables, okay? Min as well as max. Okay. Okay. So minimum so far is I got 3. Now before it was 3. Now I've got 4. Okay. The next iteration I move to 2. When I move to 2, what do I see? 2 is smaller than the current 3, right? This is comparing. So I'll set this to 2. Is 2 greater than 4? No. So max will be 4 itself. Now I'll move on to the next element, right? When I move on to the next element, is 5 smaller than 2? No. So minimum will be 2. And if is 5 greater than 4? Yes. So we'll change this max to 5. So in the end, we get minimum as 2 and maximum as 5. That is the answer, right? So that is what you're going to return here. Now suppose instead of me giving you 3, 4, 2, 5, if I had given you 2, 3, 4 and 5, what would you say? What is the smallest and what is the biggest? You would say that 2 is the smallest and 5 is the biggest. Why? Because it's in a sorted order. So we can use this idea also. So if we use sort, if we sort the array using the function, and if we sort the array, we'll get this. So this is what I've done. I've sorted this array here. I've got this. Now the minimum is this, the first element, and the maximum is 5. That is exactly what I've done here. Okay, it's simple. But the time complexity of this is the time it's taking to execute this code is O of n log n. Okay, because sorting takes O of n log n times. But here in this array we're traversing only one, so this is O of n. Correct? I hope you understood that. Now let's look into another solution. One more thing we can do is maybe compare the elements in pairs. Okay. In order to do that, we'll again keep a minimum and a maximum variable. Minimum we're setting it to max, and the maximum we're setting it to min. Okay. And now if it's an odd array, okay, if it's an odd array, we're checking it to, if we do n and 1. So suppose um, this is a bitwise operation. So suppose if I have 5, okay, that is represented as 1, 0 and 1. Okay, if you do a bitwise and, then 1 and 1 will give you what? 1 itself, right? So if it was 4, then you would have got 1, 0, 0. Okay, and if you done bitwise and 1 and 0, it would have given you 0. So if you do bitwise and, if you're getting 1, then it's an odd number. If you're getting 0, it is an even sized array. So if it is odd, then I'm decreasing the size. Why? Because if you have even, then you will have two comparisons. If it's odd, right? Suppose if it was 6 here, the fourth element, we don't have to compare it with anyone, right? So that is why we're reducing n here. Okay, after we do that, we use the same idea. Let me go to this slide. So we compare 8 and 7 first, then 7 and 32, like this. Okay, think of this pattern, keep this in mind. So 8 and 7 we compare first. 7 is minimum, so that will be the current minimum. Current maximum is 8. Okay, we're trying to find the current minimum and current maximum when we're comparing two pairs. Okay, so we're comparing I and the I plus 1. That is the adjacent elements. Okay, so if I is less than I plus 1 element, then that will be current minimum. Else that will be maximum here. That is what I've put in this part of the code. Now, if the current minimum is smaller than the minimum element we have seen so far, that will become the new minimum, right? And if the current maximum is bigger than the current maximum, if the current maximum is bigger than whatever maximum we have seen so far, then that will become the current maximum, current new maximum, okay? So I'll return that minimum and maximum here, right? I hope it was pretty simple to understand, and all these three implementations are pretty easy to do. And I hope you guys can solve this problem on your own, mainly because you've understood the logic. Hope you all have a great day. Thank you.